Hi everyone, welcome back to C Sharp Corner Live Show. I'm your host Stephen Simon, and we are back with another episode of a product showcase. And in fact, this episode is going to be very different and very exciting, as this time I'm not your only host. I have co-host with me, Annie. She's joining. She is from CAST.AI team. And without any further ado, let's invite Annie. Hi Annie, welcome to the live
Hi.
show.
Hi. Thank you so much for having me.
So Annie, I have been knowing you for a while now, and you've been doing amazing stuff for the community. So thanks for your time today. Would you quickly like to go ahead and introduce yourself, who you are and what you do? Yeah, that would be interesting.
Yeah, of course. Super happy to. And I'm so excited to be talking with CSOP Sharp Corner again. Very excited to chat once again here. But yeah, hi to everyone. I'm Annie. I am the product marketing manager at CAST.AI. Joined rather recently. It's a very nice company in general. And as far as my background goes, I have been, as Simon said, really highly involved with community activities for a long time now. I run my own podcast called Cloud Gossip. I've been organizing the CNCF and Kubernetes meetup in Finland for over 3 years now. And I also speak a lot at international tech events. But yes, nowadays, the product marketing manager at Cast AI.
Absolutely amazing. Annie, you did say that you recently moved to Cast AI. Could you give a brief introduction about what is Cast AI and what's the product all about?
Yes, very much so. So Cast AI combines instant AI-driven cloud optimization with Kubernetes. It's one platform that cuts your cloud bill in half, boosts the power of DevOps by 10, and guarantees business continuity by preventing downtime. And that's kind of the, the gist of it. But what it actually means that we are building the industry-leading cost optimization platform for Kubernetes. And at the moment, we have the best offering essentially for AWS EKS, and we will come up with the GKE and the AKS version very soon. So stay tuned for updates on that front.
Wow, that's great. Now, and if everyone's watching now, if they look at the title of today's show, it clearly says that cut your Kubernetes cloud bill in half with Cast AI, right? That's a pretty bold statement to make, right? That to cut to half. And I've been visiting your website from past couple of weeks. First, absolutely amazing website. I highly encourage everyone to visit Cast.ai website. They have built it very nicely, and you say that we're going to build it to half. How does this thing actually work? Can you give a brief idea about that?
Yeah, of course. Well, essentially, for like a quick brief, it is the wonderful AI that we have created within the company.
Hmm.
The company itself is a bit over a year old, 1 year and a half about. We launched the product during KubeCon Europe a month ago. But I think the best way to really experience the product, to get to know the value, to get to know what happens and how it happens, will be within the demo that our amazing CTO has agreed to do quite soon to us.
Yeah, exactly. So everyone's watching. Stay tuned as we're gonna have a hands-on demo by Leon. He's gonna do a demo on Cast AI. Before we move that in just a couple of minutes, Annie, it did seem that you have a community background. You have been speaking it, and now when you move to Cast AI, definitely the community part is very very important too. So how would someone get connected with the community? If you have any channels or platforms, people can go and connect with other people who work in the same field.
Yeah, of course. We are really loving the community that we're building and we already have up and running, and very much welcome everyone to join. We're super happy to help you get started, to help you get involved with Castea as well. We have a Discord and a Slack channel that everyone can join. If you need help joining or you need help using the product, always happy. I'm very happy to receive your questions. You can reach out to me on Twitter or obviously to the Castea official accounts as well. We have a really wonderful customer success team, really very happy and ready to help you out as well. So either to me or the Cast AI official ones if you have any problems. And I think the Slack community is also a really great place to start to get involved as well.
Absolutely amazing. So, what you just did say, I did drop all the links in the comments on all platforms. So, people can just go ahead. Don't click on this right now because then you're going to leave the live show. Click on these links after we end the live show, and it will always be there. So, go ahead and be a part of that community. and yeah, connect with other members too. Having said that, Annie, I think it's time to go ahead and invite Leon, who has been very kind of waiting behind the scenes. So uh, yeah, let me add him. Hi, Leon. Welcome to the live show.
Hey guys, what's going on? How's everyone doing?
We're doing
Doing well.
great. Annie have been talking about some CAST.AI, an overview. It looks pretty promising. And yeah, so looks like next 15, 20 minutes of hands-on demo on CAST.AI should be absolutely amazing. And I'm going to leave
Oh,
you both, and I'm going to go back and grab a tea here in India. Then I'll watch your demo.
fantastic. So we're doing a live demo. Excellent.
Yeah.
Good. Good. Why don't we get started? Annie, can you see my screen okay? Is the screen shared? Perfect.
Yes, I can see
Oh,
the screen perfectly.
okay. So, welcome everyone. I'm going to take you through the story kind of from the very genesis of a Kubernetes cluster. So we'll just very quickly walk through. I've pre-created a cluster because it takes about 25 minutes to create on AWS. And then we'll walk through like deploying an application and like kind of sizing your cluster and kind of the estimates that DevOps engineers make. And then we'll see why the vast majority of clusters are actually way over provisioned and poorly configured, right? Because we're all using our past experience and best efforts estimates to decide on what our initial scaling should look like and what our overall auto scaling should look like. And this is where we see a ton of room for optimization and improvement. So I'm going to get into the details in just a second. So let's go back and I'll show you what we've done. I've created an EKS cluster using AWS's EKS CTL tool. So if I bring up just my console here, hopefully you guys can see this. Yeah. So this is kind of the completion of the EKS CTL tool. I use the command to create a very vanilla default cluster with 6 nodes. I want some availability and some capacity. And then now we're kind of ready to use this cluster to deploy an application. So just a couple of setup notes. One thing I've done is I've run this really cool tool called OpsView, and I've connected OpsView to the cluster. So what does OpsView look like? It's this image right here. So I think that's pretty visible for everyone. And if you haven't used the tool before, it's basically a kind of a graphical representation of all of the nodes. There are no master nodes in this visualization because the master nodes actually sit in the AWS control plane. They don't sit in your tenancy as an AWS customer. So all we see here are the data plane nodes or the worker nodes, right? So we've got about 6 nodes here, no application deployed. So our next step will be, let's go ahead and deploy the application. So I'm going to use the command line tool to do that. I've got my little C# corner demo here. And let's do this. Let's apply. And I think oh no, let's see what the demo is. Boutique, right? So this is an eShop demo that we're going to use. It kind of comes from Google open source. I'll show you the app in just a sec. Very, very simple e-commerce app, but let's go ahead and apply it, right? So I'm applying all of the objects. There are about 8 or 9 microservices that are being deployed. Some of them are well replicated. And if we actually look at the ops view right now, you'll see that all of those pods or deployments are being deployed. So in just a second, this whole app will get deployed. If you wanted to take a look at what the actual app is, it's demo.cast.ai, or sorry, democastai.co. And it's just a very simple app that basically runs a shopping cart, payment microservice, a recommendation microservice, and so forth. Cool. So if we go back to the operational view, we should see the app kind of fully deployed here. But there's a problem. What's the problem? You might be saying, well, Leon, okay, I deployed my app. I've got 6 nodes. Like, what better can we do? Well, the problem is that the Kubernetes by default and the default scheduler is attempts to utilize all the resources at its disposal. So it just deploys all of the apps across all of the nodes. So if I had 10 nodes, I would be using 10, the app would be distributed on 10 nodes. Well, what happens there? Well, everything becomes severely underutilized. So in terms of requests for CPU and memory, we're really just scratching, we're not using hardly any of the cluster. So this is where CAST comes in. So now we've got a vanilla EKS cluster, we've got our application deployed. Let's now take the next step, which is to really connect the cluster and get some insight into what we could be doing better. Cool. So to do that, you register on CAST. You'll get my view as kind of lots of clusters that are already been used. You're going to get a walkthrough view as you do this. And what we're going to do is we're going to add a cluster to our configuration. But instead of creating a cluster, I'm just going to connect an existing one. So this is like an existing cluster that you've had. CAST had nothing to do with its creation. So we're going to go ahead and connect cluster. Excellent. So now what we have is we have a very simple set of instructions. And by the way, you'll see there are different tabs for GKE, for COPS, which is Kubernetes Operations Tool, and AKS is coming soon. Like the GKE and COPS pieces were just literally released a couple days ago, or maybe this morning. So I personally haven't tried GKE yet. I've heard the results are pretty cool compared to AWS as well. Cool. So let's go ahead and grab this curl command, and then we'll go back to my console, and we're just going to apply it. And what is this going to do? It's going to make an API call to CAST, and it's going to deploy an agent. So if we go back to our ops view, we should see, oh yeah, there's an agent, a little daemon that's deployed. And what's the response? And this is a read-only. Notice how we didn't ask you for access keys. We didn't ask you for any types of permissions. This is a pure read-only agent, and it's open source, so you can see exactly what we're doing in your environment. One of our principles is if we install software in your Kubernetes cluster, you should be able to see exactly what that software is doing. So right now, what the agent is doing, it's collecting all your pod information, all your node information. It's using AWS's instance metadata service to go and pull for all of the details around the financials, the instance type, is it burstable, what's the architecture, is it ARM, is it Intel, and so forth. And if we go back to the console, we'll see now that we've got our C# demo savings report is available to see. Excellent. So first time I'm running this today, so let's give it a whirl and make sure we've done the appropriate sacrifices to the demo gods. Awesome. So what is this savings screen saying? It's saying that you should be paying less than, you should be paying 66.5% less than you're paying now for this cluster. So let's take a look. Right now, at the bottom, there's a bottom table here that says, look, you're currently paying for 6 M5 large nodes, and M5 stands for memory optimized, right? So it's 8 gigs of RAM relative to 2 CPUs. You're paying about 10 cents an hour, which sounds pretty good. It's all reasonable, but your cluster is ending up costing you $414.72 a month, right? So that's not great, especially since CAST is saying, look, we can get you down to $138 a month, and your monthly savings should be around $275. If you add that up for the year, you're saving yourself $3,300. That's a pretty good MacBook with an M1 chip if you can save that money. So I would save these dollars anywhere I could. Right? So now you may be saying, okay, Leon, great. So what are you suggesting here? Well, the first thing we're suggesting is these M5 instances aren't right for you. After the analysis of your workloads, and we've done all of the kind of pre-calculations, looked at all the permutations of the nodes that we can possibly use in AWS, we're saying we believe that you should be running on 2 C5A large nodes, and then you should be using a spot instance. So very, very quickly, for those of you who don't know what a spot instance is, only about 7% of AWS customers use spot instances. And here's why. A spot instance is a computer that you get from AWS at a severe discount. You can get, depending on the popularity of the computer, It could be 60, it could be 50% off, 60% off, 70% off, and there are some obscure version instance types that are like 80% off. So why doesn't every customer use spot instances, you may be asking? Well, the reason why nobody or very few people use spot instances is because it creates chaos. When a real customer, someone who hasn't bought that instance type as a spot, comes to you and comes to AWS and says, I need a computer urgently, I'm willing to pay on-demand prices, AWS gives you 2 minutes, or will remove that instance from your environment within 2 minutes, and you have to terminate everything and wrap up all your work within those 2 minutes and give the computer back, or it'll be forcefully taken from you. With Google, it's even worse. You only have 1 minute to relinquish control of the computer. So one of the key kind of findings that we've had, and the key operational eurekas we have, is we can fully automate the interruption process. So we and I'm going to show you this, guys, as part of the demo. We basically intercept the lifecycle of these spot instances, and we replace that instance with either another spot instance, maybe a different instance type, maybe an on-demand instance, depending on market pressures. So if there are no spot instances available at the moment, not to worry. We just go back to inventory. We pull the next most appropriate on-demand instance. And when the market opens up again, we'll just replace it again. So it's a very hard problem to solve if you're automating it yourself. This platform makes it super simple. Like, you just turn on a policy, which I'll show you in a second, and all of the spot instances will get, all of that management will get automated for you. So why are we recommending 3 nodes? Last point on the savings report. We're recommending 3 nodes because it's kind of the minimal node count you need for a reasonably highly available setup, right? So you don't want to have a single point of failure. You don't want to have 1 node. So we kind of recommend an odd number of nodes, either 3 or 5. And in this case, we're recommending 3 because of the size of the workload. So enough yammering. Let's get started and actually do the savings. So what I'm going to do is I'm going to click on the Start Savings button. And sure enough, CAST platform does need to have some greater level of access to your cluster. So what we've done is we've pre-created a script that you can run in shell that will create a role. And let me describe it while we're running so that we're not wasting time here. So what will this do? It's going to create a role. It's going to make sure that my current access key has all of the valid access to touch the CKS cluster. It's going to then create very specific permissions for our, and I'm going to kind of flash this and then I'll delete it very quickly afterwards, but it'll create a very specific user with very specific policies that will only be scoped to the VPC and the cluster that we're considering. So in other words, it's not God access. We don't have access to your whole account with this set of credentials. We just have access to manage this cluster, and very specifically, it's managing the node groups, and it's also able to create new EC2 instances and add them to the cluster. Cool. So while that's creating, let's go to our EKS cluster. I just want to make sure that we look at the auto scaling group for a second. Cool. And then the auto scaling group that we have is this one. This auto scaling group has a desired capacity of 6 and a minimum capacity of 6. So we're going to just change the minimum capacity to be 0 so that we don't let the auto scaling group kind of get in the way of this particular script. Cool. So now we've got our access key and we've got our secret. I'm going to go ahead and plug that into the CAST console. So we've got our access key, we've got our secret, and then the only thing that we have to do is give access. This script is going to go, this service is going to go ahead and validate that, yeah, oh, we got a bad request. So let me just make sure that I've copied this correctly. And I've copied this correctly. One thing I cannot control is the AWS control plane. So let's see if this works, and then we'll be able to kind of take you to the, yeah, it's not very happy right now. unfortunately.
No worries. There was a few questions from the audience as well. If we want to take them while we see. Oh, did it?
Yeah, well, do you want to take a couple questions, or do you want to kind of continue the flow, Annie? What do you think?
Yeah, maybe we could have a few questions and then we can continue, just to because there was quite a lot already. So
Awesome.
I think we covered this a bit already, but I think it's good to repeat. Which clouds are supported by CAST AI?
Cool. So AWS, EKS is supported right now. Within a couple of weeks, you're going to be able to do the exact same process on Google, so on GKE, right? So these are Kubernetes managed services on those clouds. And then we have in a couple of weeks, you're also going to be able to, if you've created your own clusters using COPS, which is Kubernetes operations tools, you'll be able to use CAST as well for COPS. And then within a couple of months, we're also going to be supporting Azure's managed Kubernetes platform, which is called AKS, or Azure Kubernetes Service.
Perfect. Then the other one is, will Azure and CAST AI bill be separate or together, or I guess any cloud bill and the CAST AI bill?
Yeah, great question. So we don't buy the compute on your behalf, right? These are your accounts. So in the Azure context, it's called a resource group, and your bill remains inside of Azure. And then CAST just charges you a very small management fee. So it's not nearly in the scope of the cloud bill. So you'll get a bill from CAST, and you'll get a bunch of billing reports from CAST showing how your clusters are trending in terms of their spend. But the actual bill you pay is for Azure or AWS or Google, any cloud that you work with today.
Perfect. And the last one for this middle Q&A session, am I giving my data to a third party?
So you are, so it depends. So are you giving user data to a third party? No, your data stays in your data plane. So if you've got a database with user data in it that needs to be protected from a PII perspective or from a data residency perspective, nothing changes. Are you giving any data to CAST? Yes, you are. You're giving some data to CAST. What are you giving us? You're giving us access to your pod configurations, right? You're giving us access to your node configurations, but you're not giving us access to any of your secrets in Kubernetes. In fact, we make sure that we scrape all of those out before we send any data. So there's a filtering process to make sure that no sensitive data makes it to CAST. So we're really looking at your workload characteristics. We don't care about anything else. If you have secret data that is actually exposed unknowingly, like let's say in a config map or something like that, our plan is to warn you about those things. So on top of the savings report you saw, we're going to actually have a conformance and security report that will tell you, hey, you've got some weak links here. You've got a config map with a database password that shouldn't be there. Take care of it and remove it. So yes, you are revealing some workload related data to CAST, but you're not revealing any user data to CAST, if that makes sense.
Perfect. I think then we can continue with the demo.
Awesome. So let's start optimizing. So we got our cluster connected now, and we really want to see some of these savings, right? So I'm going to walk through some of these steps a little faster now. There are 4 basic policies that you have to set. The first one is just a limits policy. I don't know. Let's just up this to 40, so we don't have a cluster that grows too crazy based on workload. We want to enable the node autoscaler. So when unscheduled pods occur in your environment, we are going to then create infrastructure to manage those unscheduled pods. We also want to enable preemptive instances or spot instances in AWS's case, so that we can take advantage of the cheapest possible inventory. And then finally, no good to scale up a cluster if you can't remove it. So this is kind of where some of the magic comes in. So what you want to do is enable the node deletion policy, right? Before we do that, we're going to install this little add-on called an evictor, right? So what I'm going to do is, I'm going to open our documentation, and I'm going to go into this little command, and I'm going to, I think the Helm repo is already added, but I'm going to install a Helm chart in this cluster that's going to install our evictor component, and we're going to watch it do its magic in just a second. So actually, maybe let's do this. Let's let's enable the node deletion policy here real quick. And now let's go ahead and install the evictor. This goes back to, I'm going to clear the screen so my access keys aren't on the screen. And I'm going to add the Helm repo, and then I'm going to install the evictor. So you see evictor does not exist, installing now. Awesome. So it's up and running. And in fact, remember, if we go back to our Kubernetes ops view, oh, cool. Now we see the evictor is installed on one of the nodes. And actually, if you look into the evictor logs, you'll see it's doing leader election because it's highly available. And after leader election, it's going to start working on the following problem. You see how we have this nice distribution of pods all over the place? Well, this is just too much distribution. So what the evictor does is it works with our SaaS data collection platform, and it says, which one of these nodes are the worst from a cost effectiveness perspective? We're just going to pick one victim now. And that victim is going to get drained, and the evictor is going to do its magic in terms of moving the pods to another schedulable node. And one of the things that we do is a pre-flight check to say, look, if we bring down this node, or if we drain this particular set of pods out of the node, are we going to bring down a service? If the answer to that is yes, the evictor will reject the victim and will move on to find another victim. So you guys see the red here that's shown up. Basically what it's done is it's targeted that node, and it said, look, go distribute the work on other nodes. This node is gone. And it does it by tainting the node, so no other scheduled work can occur on that node while we're doing this kind of bin packing process. So really, this is a bin packing problem. How do we get the best and most efficient use out of a cluster by packing in all of the workloads into the fewest possible nodes without sacrificing uptime and without sacrificing availability? So if we wait another couple seconds, what we'll see probably, let me make sure that I did, now I'm like, yeah, I did turn on the node deletion policy. If we wait another couple seconds, what we'll see is the node deletion policy will kick in, and there is a TTL because you don't want to take too drastic of an action on this cluster. Within about 10 minutes, you're going to see that that node will disappear, and that it'll probably choose at least 2 more victims. And our whole goal is to get, let me open the screen kind of in split mode here. And our whole goal is to get the savings report as close to optimized as possible. So what we see here is the savings report has already said, cool, you've already enabled all 4 of your policies. You started the journey, and we're looking for this green bar kind of to flip into the optimal zone. I don't know if we're going to get there because of the time we have, but I think we're certainly going to see some marked improvement as this node goes away. So what do we see here? Oh, now we have 1, 2, 3, 4, 5 nodes. These 2 little pods or daemon sets, they're going to go away. And then within a few seconds, the savings report progresses. And what we call this the slow and low migration strategy, because our whole goal here is to do the migration and the node reduction and node creation very slowly. We don't want to do anything that will jar your production or your pre-production environments. So our whole goal here is to go slow and low, and then within a few hours, you have a really nicely optimized cluster. So let's take a look at the savings report here and see what we got, because I think we should have a little bit of savings coming up now. Cool. So you guys see that the cluster cost dropped from $414 to $345. And now you see that now there are 5 nodes, and eventually that will kind of trickle down to 3. And by the time we're finished with the process and go through the life cycle of adding nodes and deleting, adding pods and deleting pods through normal life cycle, we're going to get to this $138 kind of optimized environment. So Annie, I don't think we have time for another cycle, but hopefully this gives folks a great idea of how the product works under the covers. And we'll be able to take folks through this in more detail. Come onto our Slack and or Discord, and we'll walk you guys through it.
Perfect. I think that's the great next step. Before the final kind of comments, There was another question on is there any white papers available? And I can at least say that there will be actually a white paper published in a few days. So no worries, keep your eye out for that. But obviously, if Leon, you have anything to add, you can do so.
Well, you are much more versed in that on that side than I am. So yeah, I think we have a whole bunch of stuff in the pipeline, case studies and white papers. It's going to be really exciting when it all comes out.
Yeah, so stay tuned for those. But that's starting to be it. But I think I really want to emphasize to everyone but that you can go to CAST.AI and get your free trial and the always free analyzer to see and analyze your cluster cost. And after that, optimize it. Is there any more? Yes, I think that the link will be up on all of our feeds, so you can click through that and get started on using and optimizing your clusters.
Yeah, and just as we were talking, another node got uh, uh, signaled for as a victim. It's getting cleaned up right now, and then we'll start to see that cluster shrink to its full optimized capacity.
Perfect.
Okay.
Absolutely amazing. Well, it goes all over my head now, but looks like people really enjoyed your session. People did ask. Leon and Annie, looks like this is an amazing and promising product, right? I already see your website. Apart from all this community and all, do you have like docs or something or a place, any other call to action resources if someone wants to go and really learn more about it? Would you like to go and talk about that, and then we'll wrap it up?
Yeah, of course. I think the best place to find, we do have extensive documentation in the site as well, where you can see all the things. You can reach out to any of us and we will help you get started. Join the Slack group. And I think one of the best links is the EKS Optimizer link that you can use to straight jump into the EKS landing page and find out more about that product there that we showcased today.
All right, everyone. So I think that's the wrap. Thank you everyone for joining. I see people really love the session. Lauren says thank you. Asipo says a great session. Thanks for joining in, Asipo. Pooja says interesting session. Aesthetic World says interesting session. So it looks like people really loved your demo and the product. Leon, thank you so much for your time. Once again, I really appreciate it. Any final thing you want to plug in before we close the show?
Yeah, I mean, guys, from my perspective, this is all about saving your time. Uh, our mission here is to get you out of the plumbing and into the higher order thinking. There's no reason for us in 2021 to be doing these low-level operations manually. So really encourage you to try the automation. And I'm really excited about kind of the next steps that we're going to be taking. I believe they will be industry changing even more so than what we've shown you today. So really looking forward to showing that. And Simon, maybe when we have some of those interesting demos that come up, we'll revisit and have a chat with the community again.
Yeah, we have an Azure Summit coming up in this September. That's with like 120 speakers. If time permits, we would love to host you back there too. It's an amazing event that we are doing. So thank you once again, Leon and Annie, and thank you everyone who's joining. That was it. This episode of Product Showcase. My name is Stephen Simon. This time co-host with Annie and an amazing guest, Leon. We'll see you in the next episode of Product Showcase. Until then, take good care of yourself and get vaccinated.
Okay.